Hello and welcome to my first e-video lesson. Today we're going to look at a lesson on 4.4a, Combinations versus Permutations, Day 1. Before we begin with the difference between combinations and permutations, I want to first refresh ourselves with what a probability actually is. Okay. The probability that an event E will happen is going to be notated by the probability of E is equal to the favorable outcome divided by the total. That is what the definition of probability is. So for instance, let's just come up with an example. Let's just say that I have 20 marbles in a bag. And I know that 8 of those marbles are red and 12 of them are blue. And let's say I want to know what is the probability of choosing a red at random. Okay, the favorable that we want is a red marble, so that's going to be 8, divided by the total marbles that we have in the bag, which is 20. The probability of choosing a blue, therefore, is 12 divided by 20. Note that probabilities, because the favorable must always be smaller than the total, probabilities will always be between 0 and 1. Always. There will be some lessons in the future where we will be looking at percentages, and percentages will be between 0 and 100, but probabilities will be between 0 and 1. Okay. So take a moment, write anything down that you need to, pause the video. Okay, now let's look at the differences between permutation and combinations. Okay. First, let's look at the formula for them. A permutation, NPR, meaning n things taken r at a time, is going to be found by doing n factorial divided by n minus r factorial. Now, I'm not sure if you've seen factorials before in Algebra 2, but a factorial is essentially, if you have 5 factorial, what that's saying you're doing is you're doing 5 times 4 times 3 times 2 all the way down to 1. 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. Okay, and you can do these for any positive integer. Now, one thing to note is that when you get 0 factorial, we're just going to define that as equal to 1. Okay, and that will occur in some cases, because if you subtract off 2 of the same numbers, you'll get 0 factorial on the bottom with permutations. So, for instance, if I have 10p3, then I'm going to have 10 factorial over 7 factorial. If I have 6p2, that's going to be 6 factorial over 4 factorial. Notice the top is always the first number, that's your n value, and the denominator is going to be subtracting those two numbers factorial. Okay, and the formula for a combination is going to be NCR, and it's very similar to the permutation, except there's one thing that's added into it. So we still have n factorial over n minus r factorial, but we're going to add an r factorial in the denominator. Okay. So, for instance, if I have 10c3, that's going to be 10 factorial over 7 factorial times 3 factorial. Okay. If I have 6c2, that's going to be 6 factorial over 4 factorial times 2 factorial. Okay, so those are the formulas for both of them. Now the question is, when do you use which? Okay, for a permutation is always used when order matters and when order is important. So you'll see words like arrangement. Okay, there's a certain arrangement of things. you'll see words maybe like things have to be in a row. Okay. Combinations, order does not really matter. And you're looking at things like committees of people or things. Committees. Okay. Or you might see something like randomly selected. Okay. Although that occurs a lot in these problems, in not just in permutation and combinations, but with other problems as well. Okay. But order is not important. So that's just the basics of permutations and combinations. Now there are some common ones that occur a lot. Okay. Now if r is equal to 1, meaning if you have something like 5p1 or 5c1, okay, that's just going to be equal to n, whatever the number is. So 5p1 will be 5, 5c1 will be 5. So also, for instance, if I have 10c1, it's a 10, and I have 10p1, that will be 10 for both of them. Okay, that is a property of combinations and permutations. Okay, and you can verify that by plugging it into the formula. With combinations, there's an additional property that only works for combinations, and this will be applied in future lessons extensively. Okay, if you have something like 5c2, that's going to be the same thing as 5c3, because 5 minus 2 is 3. So if you see something like 10c9, you can say that's going to be the same thing as 10c1, which, as we just saw before, is going to be 10. Okay. For permutations, the specific property for those okay, so permutations have their own property. If you have the same number, like 5p5, that's just going to be 5 factorial. Okay. If you have 8p8, that's going to be 8 factorial. And if you see something other than the same number, okay, then you're going to have, like maybe for instance, 10p4. What that's saying is you're taking 10 things 4 at a time, means you're doing 10 times 9 times 8 times 7. It's a little shortcut we'll be seeing in a moment. Okay. Take a moment, write anything down that you need to by pausing the video. Okay, moving on to some examples. Okay, so let's look at some practice problems. So what we're going to be doing is we're going to be asking ourselves, is this a permutation problem or a combination problem? And we're going to be doing that by answering that question by seeing if there is order that is necessary in the problem. Okay, if order is important, it's permutation. If order is not important, it must be combination. Okay, so let's look at this problem. It says, in how many ways can 6 people sit in 4 chairs in a row? Now looking at that, you might see in a row and say, well, that means order matters, so this must be a permutation. And if you said that, you are correct. Okay. So the question is, how do I use permutations? Now we have 6 people sitting in 4 chairs, which means we have 6 things taken 4 at a time. So we have 6p4. Okay. Using our formula, we have 6 factorial on the top, and we're going to divide by 2 factorial. Now you can type this into your calculator, but I think it's a good idea to be able to calculate these by hand. Okay, so let's write out what the factorials are. We'll simplify as needed. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. Now with all these permutations and combinations problems, when we use the formulas like this and write it out long way, they will always cancel nicely to become integers. Okay, so for instance, these 2's cancels and these 1's cancel. So we just essentially have 6 times 5 times 4 times 3. So if you type that in your calculator, what you'll get is 360. Okay, so there are 360 ways that 6 people can sit in 4 chairs in a row. Number 2, find the number of 5-letter words. Words in quotation marks mean some of them won't actually be words. 5-letter words that are formed from the word melon. Okay, so notice first there's 5 letters in melon. Okay, so we're taking 5 things, 5 at a time. And notice when you're writing a word, order is important. So this is again another permutation problem. Okay. We're taking 5 things, 5 at a time, so it's 5p5. So that would be 5 factorial over 0 factorial. Recall from the front that 0 factorial is going to be 1, so this is just the same thing as 5 factorial, which is 5 times 4 times 3 times 2 times 1, which gives us a grand total of 120 words. Okay, now you could list them all if you really wanted to, but you can feel very confident that you have 120. Now that kind of makes a little sense too. If you think about place value, there's 5 places letters can be. Once you choose 5 choices for the first slot, 4 choices for the second slot, 3 remaining choices for the third slot, 2, and then 1 remaining for the last slot. Okay, and that's why it's 5 factorial. Whenever you're looking at the number of words that you can form from a certain word, you could just go right ahead to the factorial, because you're always going to be that many letters taken that many at a time. Okay, so pause the video now, write down anything you need to. Okay, let's move on. So now let's look at number 3. Now let's look at find the number of 5-letter words from the word paper. Okay. Now, as we saw in the last example, same thing's going to happen. This is going to be a permutation problem. Okay. So it's going to be 5p5. But in this case, what's happening is we have a letter that repeats. In the last problem, the word melon, there were no repeating letters. But in this one, we have a P repeating. And if you don't want to count that twice. Okay, if you put a P down, you don't know if you're going to be using another P, so we have to account for that double letter in some way. So what we're going to do is we're going to divide by however many times that P occurs. So there's 2 P's, so I'm going to divide by 2p2. Okay. Essentially what you're doing is you're doing 5 factorial over 2 factorial. Because remember that property of permutations is that if the n and the r are the exact same number, it's just that n factorial. Okay, and that's what you're going to happen. So there's 2 p's, so you're going to divide by 2 factorial. 5 letters, you can start off with 5 factorial on the top, divide by the 2 factorial. So let's calculate what this is going to be. 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Those cancel. 20 times 3 is 60. Okay, so there's 60 different words you can form from the word paper. Okay. All right, let's look at number 4. This is a similar question, just using numbers. How many 7-digit numbers without repetition can be made from these digits right here? Okay, so notice there are some repeated numbers as well. And notice there's 1, 2, 3, 4, 5, 6, 7 of them. So we're going to start off, by the way, this is another permutation problem. Anything that's talking about the arrangement of letters, it's a permutation, or arrangement of numbers. Okay. So we have 7 things taken 7 at a time, so 7p7. But we have some repeating digits here. We have 3 that appears twice, so I'm going to divide by 2p2 because there's 2 3's. I also have 3 6's, so I'm going to divide by 3p3. So this is for the 3's, this is for the 6's. Okay, that looks like a 5. S. S. Okay, 3's, 6's. Okay, so let's calculate what this is going to be. This is going to be 7 factorial over 2 factorial times 3 factorial. Now notice 7 factorial is, again, some getting a little bit larger than what we've been looking at so far. So here's a little trick you can do. We know we're going to have to cancel with the 3 times 2 times 1 with the 3 factorial. So I'm just going to write this out. 7 times 6 times 5 times 4, and then I'm going to write 3 factorial. Because when I do the next part, 2 times 1, which is the 2 factorial, I know it's going to cancel with that 3 factorial. Okay, because 7 times 6 times 5 times 4 times 3 times 2 times 1 is 3 factorial at the end. Those cancel nicely. Makes your work a little bit less work. A little less you have to show. The 2 cancels with the 4 to leave a 2 on the top. So I essentially have 2 times 6 times 5 times 2. All said and done, gives me 420 7-digit numbers with those particular digits. Okay, so for these ones we have like number 2, number 3, and number 4, where you're asked to find how many 5-letter words or 7-digit numbers and so forth. You could write these using just the factorials. Okay, that would be completely fine if you want to start right there, because that's typically how you would approach that in some cases. But I just wanted to point out that it is essentially a permutation problem. Okay. Now problems like number 5 and number 6 on this worksheet, on this note sheet, are a little bit different. They're technically permutation problems, but there's some conditions that are involved. Okay. First condition for number 5 is that you have a 3-digit number. And the second condition is that the numbers have to be greater than 400. And we have 5 digits to choose from. Okay. So 3-digit numbers, the best way to do these, in my opinion, is to actually write the place value for all 3 digits. And look at the conditions. Okay, you have to be greater than 400. That means that there's certain things that the first digit can only be. It can't be a 2, can't be a 3, but it could be a 4, a 5, or a 6. Okay, so there's 3 possibilities for that first digit. Now what I'm going to do is I'm just going to choose one of the possibilities and say, let's assume I used it. Let's say I used the 5. Okay, the 5 is out of the window now. There are no more conditions here. So the rest of the remaining 2 spots could be filled out with the remaining numbers. Okay. So I have 4 digits remaining, so that means the second digit has 4 possibilities. Let's just say that that ended up being a 3. I'll cross out the 3. And I have 3 remaining, so 3 remaining for that last one. Okay. So that 3 at the very beginning was because you have to be greater than 400. The remaining 2 slots are just whatever's left over. So the number of 3-digit numbers greater than 400 is going to be 3 times 4 times 3, 12 times 3, 36. Pause the video now and write down anything you need to before moving on. Okay, let's look at number 6. So this is another similar problem. This one's saying how many 3-digit even numbers greater than 500, so there's 2 conditions on top of being 3 digits, and this one can be made from these digits right here. Okay. So I'm going to start off again by writing 3 blanks, 1 for each digit. And I have even numbers, and has to be greater than 500. So this last spot must be even, and this first spot must be greater than a 5, or equal to, okay, because it could be greater than or equal to 500. So technically the last one could be greater than or equal to 4, okay, in number 5. But okay, so number 6, greater than 500 for their first digit, and it has to be even. There's only 2 possibilities for 5 and above, so 5 and a 9, so I'll choose a 5. Okay, but there's 2 possibilities. In terms of even numbers always end in an even number, so we have only 2 and 4 to choose from, so we have 2 again. Well, let's just say I use the 4. And there's only 1 spot left, and there's 4 digits left to choose from, so it's going to be 4 remaining choices for that middle digit. 2 times 4 times 2, 16 possibilities. Okay, so for these problems, we're talking about 3-digit numbers from a set of numbers. Sometimes it's good to set up the digits and look at the conditions, okay, and reason it out that way. Okay, now we've seen a lot of permutation problems so far. Question is, are we going to ever see any combinations? And the answer is yes. In number 7. In number 7, we have 5 students are chosen as possible defenders on a team. In how many ways can they choose 2 people, 2 members to do the job? Now, you can pick any order that you want to be on a team. So this order does not matter. So this is going to be a combinations problem. We have 5 total students. We want to have 2 members do the job, so we're essentially doing 5C2. 5 things taken 2 at a time through combinations. So let's just review the little formula that I put in the front side. So NCR is going to be n factorial over n minus r factorial times r factorial. Okay. So what we essentially have here is 5 factorial over 3 factorial times 2 factorial. Notice with combinations, by the way, these 2 bottom numbers in the denominator right here will always add up to whatever's in the top. So 3 plus 2 makes 5. Okay, you'll always have that in combinations. So let's do some calculations. So notice there's a 3 factorial on the bottom, so I'm going to write the top as 5 times 4 times 3 factorial. And I'm in the bottom, we'll do 3 factorial times 2 times 1. The 3 factorials cancel. 2 and the 4 cancels to make a 2, so 5 times 2. There are 10 ways you can choose 2 members to do the job out of 5 students. Okay. So this is a good combination problem. Okay, let's look at one last problem. There are 7 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Okay. This one is definitely going to be a permutation, because the order is going to be important. Gold, silver, bronze, there's a certain order to that. Okay. It's going to be 7 things, 7 finalists, for taken 3 at a time, P. Okay. 7P3. Let me write that a little better. 7P3. So it's going to essentially be 7 factorial over 4 factorial. Which is 7 times 6 times 5 times 4 factorial over 4 factorial. So 7 times 6 times 5. Notice 7P3 shortcut, usually you can multiply only the first 3 of the factorial. 7 times 6 times 5. That will work as well. That's a shortcut for using the formula. 7 times 6 times 5 is 210. So that's how many ways gold, silver, and bronze can be awarded. Okay. Pause the video and write down anything you need to. Okay, so I want to thank you for watching my first video lesson. Okay, tomorrow in class we will go over any questions you have. And before you're working on the assignment, I will put some more examples on the board for you to check your understanding about the lesson. Okay. So thank you for watching, and I'll see you in class tomorrow.